Okay, so in the previous video, all of the problems that we did worked out nicely, where the radical simplified to be a nice number and there's nothing left over. Well, what happens when it doesn't simplify very easily like that? Well, that's what we're going to do with this last example. So let's look at this one here. I have the cube root of 120 x to the fourth, and I want to simplify that. So I'm going to write this again as the cube root of 120 times the cube root of x to the fourth. The cube root of 120, I don't know what times itself, or if there's anything times itself 3 times, that would give me 120. So I'm going to do a factor tree. 120 I know breaks down to be 10 times 12. 10 breaks down to be 2 times 5. 12 breaks down to be 3 times 4, and 4 breaks down to be 2 times 2. Now all of these are prime numbers. But it's a cube root, so for every 3 of the same number I get to take one out. Well, I have a 2 here and 2 2's here, so I have 3 2's and a 5 and a 3. So every 3 of the same number I get to take one out, so I get to take out a 2. But I can't do anything with this 5 and the 3, so I'm going to leave those under the radical, meaning I have to multiply those together, and just 5 times 3 is 15. And I'm going to leave those under the cube root. So the cube root of 15 can't be simplified. Now let's go over to the x. 3 goes into 4 one time, meaning I get to factor out 1x. But when 3 goes into 4 one time, it doesn't work out evenly because there's 1 remaining. So x to the first, or just x, would be remaining under the radical. So now when I combine these together, now for my final answer, the 2 and the x are both on the outside of the radical, so I'm going to multiply those together, so that's going to be 2x. Whoops. And the 5 or the 15 and the x are both under the same radical. They're both under a cube root. So I'm going to write this as the cube root of 15x. So my final answer is 2x times the cube root of 15x. So why don't you give the next one a shot and pause the video and hit play when you're ready to go. Okay, so we have the 5th root of 96 times the 5th root of y to the 11th. So again, with 96, we're going to do a factor tree for that one. Now, 96, you may know, well, it's an even number, so 2 works, but sometimes that can be a little harder to do in your head without a calculator, because again, all of these problems you're going to have to do without a calculator. 9 and 6 are both divisible by 3, so I'm going to use 3. So now when I do that, 3 goes into 9 3 times, and 3 goes into 6 2 times. So 3 times 32 would be 96, and 3 is a prime number. 32 is not prime, so I have to continue with that. And you might recognize that 4 times 8 would give you 32. 4 is the same as 2 times 2, and that's prime. 8, remember we've talked about that one a few times. So that's 2 times 2 times 2. So 96 breaks up to be 3 times 2 times 2 times 2 times 2 times 2. I'm trying to find the 5th root of that, so for every 5 of the same number, I get to take one out. So I have 5 2's here. So I get to factor out a 2, but I'm left with this 3 that's still going to be remaining under the radical, because I didn't do anything with that, so leave that under the radical. 5 goes into 11 for the next part. 5 goes into 11 2 times, so I get to factor out a y squared. Don't factor out a 2. Remember, this is a little bit different because this is the variable part. So that means I can factor out 2 y's. And I'm left with the 5th root of y. 5 goes into there 2 times with a remainder of 1. So we can just write that as the 5th root of y. So again, when I go to write my final answer, I'm going to multiply together what's on the outside of the radical. So the 2 and the y squared, so 2 times y squared would be outside the radical. And the 5th root of 3y would be under the radical. Oops. So there's your final answer. So good luck on your homework assignment, and hopefully these videos have helped.